Alright, so we're going to talk about the slopes now. I already have everything worked out here, and that's mainly because I made the video and then messed up in uploading it, so I'm having to re-record the video. So, if we're looking at the slopes, we got to look at the slopes of the same segment. So the slope of AB, I'm just going to write M for slope, and AB is the segment name. So the slope AB, I'm just going to count it out. I can go up 3 over 1, so that's 3 over 1. The slope of segment BC was here to here. I know it's going to be negative. Actually, I'm going to use these markings that are already here. I have to go down 3 and over 4, so that would be negative 3 over 4. These are not opposite reciprocals, so that would tell me that this angle here is not a right angle, which basically tells me it's not a rectangle or a square. I knew that it wasn't, but that's just one way. And if you didn't know, that would be one way that you could tell. This is obviously more than a right angle. Sometimes it's pretty close, and you can't really tell by looking. All right, a couple other things. We have two triangles to compare. So this is something we haven't done in a little while. Triangle ABC is this triangle on the left that I colored in blue. Triangle ADC is the triangle on the right. And remember, there's a lot of different ways we can show that triangles are congruent. I'm gonna show by side, 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 and just get all the side lengths of each of these two triangles. So the three side lengths that I need to compare are AB, and that would match up with AD, so I'm going to compare those two. BC down here compared to DC, those are corresponding sides. And then the third pair of sides is AC and AC. That's the easiest one, so I'm going to do that one first. I don't even need to know what the length of that side is, since that side is used on this triangle and the upper triangle. I know they have to be the same, and that's by, if you remember, the reflexive property. So that piece is done. Let's get the lengths of AB and AD. AB I've actually done before. Right here I have the square root of 10. AD, here to here, it's the square root of the difference of the y values. 6 minus 5 is 1. Square it. The difference of the x values. 1 minus 4 is negative 3. All I need is the difference, so I don't need the negative. So it's 3 squared. And that is 1 plus 9, 10, square root of 10. They match up. BC and DC, I have already done both of those right there. They are both equal to 5. So I know that those are equal to each other. So I have 3 sets of sides that are equal to each other. So these triangles are congruent by side, side, side. All right, let's look at some other sides. We got BE and ED. So what are we looking for here? BE and ED. So those are two parts of a diagonal. Basically, if these turn out to be congruent, then it says that diagonal AC bisects, or cuts in half, this whole diagonal BD. So let's take a look at those. We need this ordered pair here for E. That's ordered pair 2, 4. And I'm going to compare these two ordered pairs. I'm going to compare these two ordered pairs and get the lengths. So here we go. For BE, the difference in the y values is 1. The difference in the x values is 2. So I got 1 squared plus 2 squared. That's equal to the square root of 5. ED, in a similar way, the difference in the y values are 1. Difference in the x values are 2. So it's 1 squared plus 2 squared. Don't forget to square them. I get the square root of 5. Those are equal or congruent. And so what I know is that this diagonal is bisected. So the BD diagonal is the bisected one, and it's bisected by AC. All right. Next one, they want us to compare AE and ED. AE is here, ED is there. So this is just kind of interesting. It's nothing important really for the properties of a kite. But if those two end up being congruent, then that means these two are congruent, and you would have another pair of smaller congruent triangles here. It's kind of interesting. All right, let's check it out. ED, we already know the measure to, so let's look at AE. We're going to compare the y and x values. The difference in the y's are 2. Difference in the x's are 1. Sounds familiar. 2 squared plus 1 squared, square root of 5. So those are also congruent. Okay, the next one is AC and BD, and actually, we have done those before in number 5. We already saw that those two lengths are different. Where are we talking here? AC and BD, those are the two diagonals. So the two diagonals don't have the same length. So we know it can't be a rectangle. We know it can't be a square. It could still be a rhombus, though. What we can do is look to see if they are perpendicular. So let's check that. Let's look at the slopes. So slope BD, I need to do rise over run. So I'm going to go up 2 and over 4. I can reduce that to 1/2. AC, the slope, I know it's going to be negative. It's down 6 and over 3. So negative 6 over 3, negative 2 over 1. Check it out. Opposite signs, flip fraction, opposite reciprocals. So the diagonals are perpendicular. So what do we have? A whole bunch of stuff where we can figure out what properties of kites are, and we can test all kinds of things about that using slope and distance formula. All right, the next thing we're going to do is look at just polygons. Basically, we want to be able to prove that a polygon is a parallelogram, a rectangle, rhombus, or a square. And in your homework, I'm going to ask you to look at different types of triangles too. But what are the minimum things we need to know to prove these are true? In a parallelogram, we have to know that both pairs of opposite sides are parallel. In a rectangle, we need both pairs of opposite sides parallel, and we need to show that one pair of adjacent sides is perpendicular. Adjacent sides means right next to each other. Basically, we want to show that a side is perpendicular and that we get a right angle. And that's a property of a rectangle. In a rhombus, we have to show that all 4 sides are congruent. And it's as simple as that. In a square, we have to show that all 4 sides are congruent and that adjacent sides are perpendicular. Remember that a rhombus can be kind of diamond looking. A square has those, 90-degree corners. A rhombus does not. All right, so here's our problem. We have this shape, and we need to know if it's a rectangle, a rhombus, or a square. And basically we're going to use the same shape for all of that. So I know in advance that I'm going to need all these slopes. I know I'm going to need all these ordered pairs. And I know I'm going to need the side length on every one of these. So I started by getting the ordered pairs. -2, 7, 2, 2. -3, -2, -7, 3. Make sure you agree with me on that. Make sure you know how to find those ordered pairs. And then I'm going to get the slope. And I can get the slope just by counting off boxes here. So here, QR, I got down 5 over 4, -5/4. S to R, it's going to be up 4 over 5, 4/5. P to S, down 5 over 4. And PQ, up 4 over 5. Now, if we just look at the slopes real quick, take a look. Opposite sides have the same slope. They're parallel. Opposite sides here have the same slope. They're parallel. How about adjacent sides? The sides right next to each other. These two. Take a look. Opposite sign, reciprocal fraction. So these are perpendicular. And I put that little right angle box in there. These two, opposite reciprocals, right angle. These two are also opposite reciprocals, right angle. And of course these are too. So there's what we have. We have, this is got to be a rectangle for sure. It's a parallelogram and it's a rectangle. It may or may not be a rhombus and a square. We need the side lengths for that. Actually, that's what I'm going to do next. I'm just going to jump down to the bottom here and do my distance formula to get all the sides. So I'm starting with QR here. I'm comparing the ordered pairs here and here. So the difference in the y values, 7 and 2, is 5. Square it. Difference in the x values, -2 to 2. That is a difference of 4. And I can just call it positive 4. It doesn't matter if you call it positive or negative, because once you square it, it's always positive. So here I have the square root of 25 plus 16, which is the square root of 41. RS, down here, difference in the y's is 4. Difference in the x is 5. Square both of those, you still get square root of 41. PS, difference in the y's is 5, difference in the x's is 4. Same pair of numbers. Square root of 41. And the final side, difference in the y is 4, difference in the x is 5. Same answer. All four sides are congruent. And you would actually write that as segment QR is congruent to segment RS, congruent to segment PS, congruent to segment PQ. The other thing we need to know for a square is that two adjacent sides are perpendicular. We already talked about that, but let's write it down. And you can pick any two sides, it doesn't matter. So I picked out PQ, this one, and PS, these two. So I can write PQ is perpendicular to PS. So the slopes are opposite reciprocals. So yes, this is a square. Well, that makes the other parts kind of easy, because if it's a square, it has to be a rectangle. Why do we know it's a rectangle? We have adjacent sides perpendicular, PQ and PS. I have it down at the bottom for justification. And then we have both pairs of opposite sides are parallel. And we show that in our picture. I can be specific. PQ is parallel to SR. Notice the symbols. PS is parallel to QR. Is it a rhombus? What's required for a rhombus? All four sides are congruent? Yep, they are. And I showed that here with my work on the square. So there you go. There is all the properties of the square, rhombus, and rectangle documented, and basically we proved and justified all of those shapes. In your homework, you're going to do, it's actually from task 8.3. I have it in a separate document. You have several sets of shapes to do similar work on. So if you have this situation where you've already done some work and you need to apply it to another problem, that's fine. You don't have to show that work twice. But please do those pages and submit your answers on Canvas. You can print out the worksheet. It's on Canvas. And write your answers on the worksheet, or you can write them on a separate sheet of paper. All right, good luck with that. Bye now.